Alright guys, let's start vodcast 4.2. We're going to talk about subatomic particles. And that's one of those sort of words that it sounds like it's some big, crazy science term. But I mean, really, if you sort of break this word down, I mean, sub means under, and atomic obviously means atom. And so what we're talking about are the particles that are under the atom, or particles that make up the atom. Okay, and you guys already know what these particles are. I mean, we're talking about protons, neutrons, and electrons. Okay, so we're going to sort of buzz through each of these. I apologize again, I don't have the pen with me. I tried to do another deal with it and it just didn't pan out, so we're just going to roll with it the way it is tonight. And so I'll try to pop everything in, and I'll probably put some pop-ins in so that you can, and you might want to copy down some of those notes as well. What you want to look for as we're going through this are how to use the periodic table to find these things, okay, how to calculate them when you can't use the periodic table, and what the charges and names for each of the particles are and where they are. Okay, so remember each of those things as we roll through, and this will go pretty quick. So if we look at our periodic table box, okay, this is sort of like something pulled straight out of the periodic table as we have before. We've got some things that we already know, so like the 15.998 there, that is our gram atomic mass that we've used before. Okay, that's what we used when we did moles to figure out how many grams equals 1 mole for that atom. And then we said this other big number was something else, and that we couldn't use that for mass. And so we're going to use that number now. That number is the atomic number. Okay, if we draw a line to it right there, that is the atomic number right there. Okay, and what the atomic number means that is super massively important for us is that the atomic number is the number of protons in an atom of that substance. So what that means for us is, if we look at this on the periodic table, that oxygen has 8 protons. Okay, now why is this so massively important to us? Because protons basically are the identity for that atom. Okay, you can't change the number of protons without changing the element. What that really means for us is that atomic number is the identity for that whole element. Okay, atomic number is the identity. Okay, you can't change the number of protons. It always has to be the same. That is what makes it oxygen. 8 protons make something oxygen. 7 protons make something nitrogen. 6 makes it carbon. 26 makes it iron. Okay, the number of protons is what makes it what atom it is. Okay, so that atomic number also tells us some other pretty important things as well. It tells us about the number of electrons as well. And so we already know from watching the videos before that the discovery of the electron, remember, electrons are the negative particles. Okay, and if we jumped back real quick, remember the protons are the positive parts of the atom, and if you recall, Rutherford discovered that protons, the positive charge, are found in the nucleus, and that we know from further experiments that electrons are on the outside of the nucleus, that they're in this sort of cloud that we'll talk about a lot more in the next unit. So back to this, I mean, what this means is that most atoms are neutral on their own. Okay, and if they're neutral, that means that the number of positives and the number of negatives has to balance out. If I have 8 protons and oxygen doesn't have a charge on it, then it has to have 8 electrons as well. Okay, now we're going to talk a little bit down the line here about ions where they do have a charge. But when that happens, that just means that we've got more or less electrons than we do protons. If I've got 9 electrons here, say, then I would have a negative charge. If I had 7 electrons, I'd have a positive, because I'd have 1 more positive than negative. Okay, so that atomic number tells us a couple of really important things. It tells us protons, which identifies the element as what it is, and then it tells us about electrons, and as we'll see in the next unit, everything in chemistry essentially revolves around electrons, and electrons being transferred and shared and bonded and all that stuff. So that atomic number becomes really super important for us. That's going to lead us into another number that is pretty important for us, and that number is called the mass number. And it's pretty simple. Basically, the mass number is the number of protons plus the number of neutrons. Now, the temptation would sort of be to go back and look at this number here and say, well, wasn't that the mass? I mean, isn't that what we've been calculating? And it is the mass, but we'll see in a second, this is the average atomic mass. It's not the same thing as the mass number. Okay, we'll talk a little bit more about why that is in a second. So if it's not on the periodic table, it has to be given to you in the problem, or you have to have some way to figure it out. So there are two ways that you can show it. The first of those ways is that an element can be written like this. It can be called uranium-238, where uranium obviously is the element, and then 238 is the mass number. Okay, so that tells us how many protons plus neutrons it has. Okay, perhaps a more useful way to show it is what we call nuclear notation or nuclide notation, and that is this right here. It has the same essential data, uranium, okay, U is uranium, and then 238 is the mass number, so the number to the upper left is the mass number. The number down on the bottom, at the lower left, is actually the atomic number. Now, what's pretty cool about this is that this actually gives us a sort of easy way to calculate number of neutrons, because if I just take the nuclear notation like this and I do my simple subtraction here, okay, I can figure out what the number of neutrons are if I could type and spell. Okay, so if I take 238 minus 92, I'm going to get 146 neutrons. And that is exactly how we're always going to find neutrons. You're going to take your mass number and then subtract the atomic number from it, and that's going to leave you with the number of neutrons. Okay? Now, we said before that you can't change the number of protons without changing what element it is. What you can change, though, is the number of neutrons. And in fact, that happens all the time. Almost every element has atoms that have different numbers of neutrons, and those have a specific name. They're called isotopes. Okay, so isotopes are the same element, but they have different mass numbers because they have different numbers of neutrons. And this is why you can't, part of the reason why you can't just put mass number on the periodic table, because every element has multiple mass numbers or multiple isotopes for it. And so if you look just real quickly at this diagram, this is the nucleus of a neon atom. Okay, the zeros here are all neutrons. Okay, the plus is obviously going to be protons. And if we counted all these up, I've got 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 neutrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 protons. 10 plus 10, that gives us a mass number of 20. Okay, so that is right there, 20. That is the mass number for that nucleus. If we went to the next one over here and counted them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, still 10 protons. Has to be, otherwise it wouldn't still be neon. Okay, neon has 10 protons always. But neutrons now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and so 10 plus 12 is then going to give us this 22 here. Okay, so isotopes mean that they have a different mass number. This is neon 20, this is neon 22. We could also, of course, write them in nuclear notation. Okay, so neon. Sorry, I'm writing with the mouse, so you know that can't go well. I don't write well with a pen. So if we wrote the mass number then, neon 22. Oh, sorry, guys. And then over here would be neon 20 instead. Now, you don't actually have to write the bottom number. It's usually best if you do, and that would be 10, because it's neon, and neon's atomic number is 10. You don't actually technically have to write it, though, because just by virtue of it being neon, we already know what the number is. We could just look it up on the table. It has to be 10. Okay? So isotopes are atoms of the same element, different numbers of neutrons. Okay? So we just sort of did a little bit of calculation there to see how that worked. I'm going to run through a couple of examples here real quick. These are two really common isotopes, and they're of a very common element, which is carbon. So remember that this number, okay, in both cases is the mass number. Okay, so I'm just going to move it down. That's my mass number. We could also write it as 14C, okay, 12C. We could do that. The atomic number for carbon, we look up on the periodic table, and it's 6. Okay, so it's 6 in both cases. And then to find the number of neutrons, we just have to do a real quick subtraction. Okay, so 12 minus 6, 14 minus 6, and that's going to give us, in carbon 12, we have 6 neutrons, and in carbon 14, we have 8 neutrons. Okay, so pretty simple. So, the reason that this is not on the periodic table, because what this is what's called the average atomic mass. And what that does is that we take all of the different isotopes. So like we go back here, we take carbon 12 and carbon 14, and we average them together according to how many of them there are. Okay, so if you looked on the periodic table and you saw carbon's gram atomic mass was 12.011, you would see that most of the isotopes are 12, and that a very small percentage are going to be 14, and that's what's going to throw that average atomic mass off a little bit. Those of you know, some of us will go over this a little bit later in a little bit more complicated way, but it's not really that difficult to calculate that. It's just like averaging a grade. Some things have more weight than others, and that's going to change the mass a little bit more. Remember that number to us also can be gram atomic mass, and it's also very commonly called the atomic weight. So you could see this called any of these things, and all of them would be equally accurate. Okay, so let's get a little bit of practice just real quick. This is pretty common that you're going to see tables like this where you're going to have to fill in the blanks, and they always give you just enough information to puzzle out everything else. So I'm going to run through this as fast as possible. You want to pause real quick, make sure that you get this, and in fact you might want to go ahead and grab your periodic table and try to figure out the answers yourself before I run through them, because I'll give you a big hint on your next quiz for atomic structure. A table like this with different elements will be on there. One thing real quick that's important to note is that the mass number right here is not on the periodic table. Okay, remember that that's the average atomic mass, that the mass number we have to figure out. Okay, and we have to figure it out by adding up protons and neutrons. Okay, so let's run through this real quick. Let me get rid of this real quick for us. Okay, so fluorine, symbol of F. Okay, pretty simple. We look on the periodic table and we see that its atomic number is 9. Okay, now remember that if we're talking about a neutral atom, the atomic number tells us the number of protons, so that also is 9, and the number of electrons. Okay, so 9's for all those. And then for number of neutrons, which is the only thing we have left, it's mass number minus atomic number. So 19 minus 9 is going to give us 10 neutrons. And apparently I forgot to put that answer in there. Okay, so let's do that real quick. Sorry about that. Now we got to make it small enough to fit. See, this is what happens when you don't have the pen with you. Okay, so 10 neutrons. Now again, how does that work? Protons plus neutrons equals mass number. Okay, 9 plus 10 is 19. And remember, atomic number is the number of protons. Okay, so on to the next one. Symbol of C is going to be element. I think I wrote chlorine here. That is not chlorine. Okay, that is carbon. Sorry that I keep having to type this stuff in. Again, if I had the pen, it'd be so much easier. Okay, so carbon. Atomic number 6, that means that we have 6 protons. Also means that we have 6 electrons because we're not dealing with anything with a charge right now. And then mass number, remember, protons plus neutrons, so 6 plus 6 is 12. Okay? So hopefully kind of getting the hang of it, and maybe you can, if you feel like you're getting the hang of it, just hit pause here and see if you can fill in the rest by yourself. But if not, we're going to go ahead and run through them. So sodium, we look up its atomic number on the table. It's 11. Okay, and really we didn't even have to look this one up on the table because it already said that there were 11 protons, and if there are 11 protons, that has to be the atomic number. Remember, that's also at this point the number of electrons. Okay, and then for mass number, we add up protons plus neutrons, so 11 plus 13 gives us 24 for our mass number. Okay, element Cu is copper. Okay. Atomic number 29, that means we have 29 protons. Again, that makes pretty good sense. And remember that that also is the number of electrons. Okay, and then we need to figure out the number of neutrons. So again, if you don't have neutrons, you take your mass number and you subtract the atomic number, or you can subtract number of protons. Those are both the same thing. So in your calculator real quick, 63 minus 29 is going to give you 34. Okay, and so that's our number of neutrons there. Okay, I hope that was pretty self-explanatory. Sorry about the lack of the pen there, guys, but hopefully that all came out pretty easily for you. Definitely make sure that you know how to do this on the table, and again, make sure that you know those things that we talked about at the very beginning. Make sure that you know that atoms are made of protons, neutrons, and electrons, okay, and that what the charge on them is. Protons are positive, neutrons don't have a charge, they're neutral, electrons are negative. Okay, and how to find them on the periodic table. So atomic number is going to tell us number of protons and number of electrons right now, and the mass number is something that has to be given to us, or we have to know the number of neutrons. All right, thanks guys.